Good morning, class. Here's Math 119A, Chapter 1, Sequences, Section 1.6, Sequences and Difference Equations. That's the starting point. One point six, Sequences and Difference Equations. Here's the summary. A sequence is a list of numbers written in a specific order, a sub 1, a sub 2, a sub n, the first, second, nth terms of the sequence. Accordingly, a sub n is the general term, and n being the set of natural numbers or positive integers, 1, 2, 3 to infinity. By the way, natural numbers, positive integers, or counting numbers, the same thing. Recursive sequence, also known as difference equation. A recursion or recursive formula defines a sequence by specifying the first few terms of the sequence and using a formula to specify subsequent terms in terms of preceding terms. The next term depends on knowing the previous one or previous ones. Form would be a sub n plus 1 equals f of a sub n. A couple of sequences that we are familiar with from algebra, arithmetic and geometric sequences. An arithmetic sequence is in the form of a sub 1, a sub 1 plus d, and so on, which means there is a constant difference or distance, where the difference d, also known as distance between consecutive terms, is constant, can be defined by, well, recursively, a sub n plus 1 is a sub n plus d. That means if you want a term, pick the previous one and add a constant. Or explicitly by a sub n equals a sub 1 plus n minus 1 times d in general. Example 15913. Notice we add number 4. So 1 plus 4, 5 plus 4, 9 plus 4, and so on. Similarly, a geometric sequence, a sub 1 times r, a sub 1 r squared, and a general term, a sub 1 r to the power of n minus 1, where each term is r times the previous one and can be defined recursively by a sub n plus 1 equals r a sub n. In other words, if you want a term, pick a previous one times r. Explicitly by a sub n equals a sub 1 r to the power of n minus 1. For example, 1, 4, 16, 64. Notice we are multiplying by 4. 1 times 4, 4. 4 times 4, 16, and we continue on that dots. Sequences. A sequence is a list of numbers written in a specific order. Measurements collected at discrete time points and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concepts of sequences, the date, and difference equations, the description of the mechanism of change. A sequence is a real valued function f, whose domain is the set of natural numbers, 1, 2, 3 to infinity. Use the notation a sub n to denote f of n. So first term, a sub 1, second one, a sub 2, and a general term, a sub n. Here's example 1. Given the general term, find the first 5 terms, a sub n equals n. All you have to do, just replace the n with 1. If n is 1, so a1 is 1. If it's 2, it's 2. So A1 is 1, A2 is 2, and that's it. You just write the first 5 terms. 1, 2, 3, 4, 5. This is a very simple one, just to get us started. Part B, B sub n is sine of n pi divided by 2. Well, replace the n with 1, we get sine of pi over 2. Replace it with 2, we get sine of 2 pi over 2 or sine of pi. Replace it with 3, sine of 3 pi over 2. 4 pi over 2 gives us 2 pi, sine of 2 pi. And if you replace it with 5, sine of 5 pi over 2. Now, what are the values? We are not finished. And I want to remind you of what we have learned previously. For example, starting with a circle, if it is centered at the origin 0, 0, according to Pythagorean theorem, x squared plus y squared equals r squared. If it's centered at h and k, x minus h quantity squared plus y minus k quantity squared equals r squared. So that's the equation of a circle. Analytic geometry. Now, if this one happened to have a radius equal to 1, we call it a unit circle. So unit circle, x squared plus y squared is 1 squared over 1. When that happens, it cuts the x and y axis at 1, 0 here, minus 1, 0 here, 0, 1 here, 0, negative 1 here. Very straightforward. So a unit circle gives us those. And as far as trigonometry is concerned, when we draw an angle, in standard position, the initial side is along the positive side of the x-axis. And counterclockwise is positive. So this is 0 degrees. This one would be 90 degrees. This one would be 180. This one would be 270. Or pi over 2, pi, 3 pi over 2. And so an angle that you see here, this is the initial side, this is the terminal side as far as the angle is concerned. And every point that cuts the unit circle has coordinates x, comma, y. Now, x is represented by cosine, y is represented by sine. Why is that? As you recall, in a right triangle, if you want to find the cosine is the adjacent, so the cosine would be the adjacent over the hypotenuse. The adjacent is the x coordinate of the point, and the hypotenuse is 1, so x over 1. Whereas the y coordinate, okay, if you want to find that, sine of this angle is the opposite sine, which is the y, over the hypotenuse, which is 1. That's why x represents cosine, y represents sine. And if that's the case, and this point has coordinates 1, 0, and this angle is 0 degrees, then cosine of 0 becomes 1, sine of 0 becomes 0. What about the rest of it? If we look at this point, that means cosine of power 2 is 0, sine of power 2 is 1. This point cosine of pi is negative 1, sine of pi is 0. is point cosine of 3 power 2 is 0, sine of 3 power 2 is -1. So we can answer those questions, but before I do that, I want to add two more things in general. Sine of n pi 0, n is an integer. Cosine of 2n plus 1 times power 2 is also 0. What is 2n plus 1? That represents an odd number. So having said that, sine of power 2 is 1, sine of pi is 0, sine of 3 power 2 is -1, sine of 2 pi is 0, and 5 power 2 is the same as power 2, becomes 1. So those are the answers. Again, I went over some information from geometry as well as trigonometry. Just refresh your memory about how we arrive at the answers. Part C of the same question, C sub n is n over 1 plus n. Well, we want the first 5 terms. So replace the n with 1. You get 1 here, 1 here. You get 1/2. C sub 2. If I replace this one with 2, with 2, with 2, I get 2/3. And you can see, of course, the rest. D sub n is the digit in the nth decimal place of pi. Please understand, pi is not equal to 3.14. It is approximated by that. It is equal to 3.14159, and it continues indefinitely. So the first digit would be 1. The first digit of the decimal. The second digit of the decimal is 4. And you can see the rest of them as well. And we want 5 of it. We want the first 5 terms. We start with the first one. In this case, a sub n is 2 to the power of n minus 4. So I want a sub 1. I'm going to replace this one with 1. A sub 1 is 2 to the power of 1 minus 4. -2. I want the second one. I'm going to replace this with 2. So a sub 2 is 2 squared minus 4. 0. If I want 3, this is 2 cubed. 8 minus 4 is 4. And I'm going to assume everybody can come up with the rest. Find the formula for the general term a sub n of the sequence. Now it's the reverse process, and it's normally by inspection. So the first one, 5, 8, 11, 14, 17, we notice that something is happening here. And the same thing happens here. And that is adding number 3. Because it's an arithmetic sequence and D can be positive or negative. So in this case, we are adding a constant 3. Therefore, we say, we notice it's an arithmetic sequence with the difference of 3. The first term is 5. So a sub 1 is 5, D is 3. And as you know, the general term is a sub n is equal to a sub 1 plus D times n minus 1. This is, remember, when we defined this, we defined it recursively as a sub n plus 1 equals a sub n plus d. And this one is explicitly, and we're going to use that. Now, replace the a sub 1 with 5, d with 3. Distribute, we get 3n minus 3, minus 3 and 5 combine into 2, we get 3n plus 2. And now, it is extremely important to check what does it mean. Replace the n with 1, you get 5. Replace the n with 2, 3 times 2 plus 2, do you get 8? And so on and so forth. Doesn't take long to check. Always do that. Part B, again, by inspection, we notice this geometric sequence because if I multiply this one by negative 1/3, I get the second one. If I multiply this one by negative 1/3, I get the third one, and so on. So it's a geometric sequence with a ratio of negative 1/3. So I'm going to write my first term a sub 1 is 1 or is negative 1/3, and I'm going to use the general term a sub n equals a sub 1 or to the power of n minus 1. And now I'm going to replace that a sub 1 with 1 or with negative 1/3. Now, you can leave it like that, but generally speaking, when we have a negative sign, especially as you can see here, it's alternating, they want us to separate them. So this one doesn't do anything. Separate the negative 1. You get negative 1 to the power of n minus 1 times 1/3 to the power of n minus 1. Bear in mind, for alternating signs, see, it changes, right? Positive, negative, and so on. That's why it's called alternating sign. Sometimes the first one is positive, sometimes the first one is negative. You start with one of those. This one, when the first one is positive. This one, when the first one is negative. If you put 1 here, you get minus 1 to the power of 1 is 1. If you put 1 here, you get minus 1 to the power of 0. As you recall, a to the power of 0 is 1, right? So if I put 1, I get 0. By the way, in some texts, instead of n minus 1, they may use n plus 1. It gives you the same answer, but we're going to stick with n minus 1. Having said that, we are going to check. To check into this, let's put n equals 1. And when we do that, everything to the power of 0 is 1. 1 times 1 is 1. So the first one checks, and I'm going to leave it for you to check the second one. Always check at least 2, if not more, just to be on the safe side. Sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one. And it may not always be possible to determine the general term of the sequence algebraically. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. The solution is a sequence, a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. A famous sequence is a Fibonacci sequence where the first term is 1, so is the second term, and then we start adding. F sub n is f sub n minus 1 plus f sub n minus 2 when n is larger than or equal to 3. What does it mean? If I want any term, I pick the previous one and the one before that and add them up. So the first one and the second one are 1. Then add these two, you get 2. Add these two, you get 3, and so on. So if I want the next one, I need to add these two numbers. Gives me 34. So that's my next tier. This is Fibonacci sequence. Happens in nature as follows, for example. Example in nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. First we have 1, the second year we have 1, and the third year they add up to 2. And the next year these 2 add up to 3, and the next year these 2 add up to 5, and these 2 add up to 8, and so on and so forth. Normally that is the case. Okay, not always, but mostly. We want to find the first 6 terms. In this case, the first term a sub 1 is given as 6, and a general format a sub n plus 1 is a sub n over n. In other words, if I want any term, say a sub n plus 1, that means the next term, I'll go with the previous one divided by n. So a1 is 6, and a2, if I make this 2, that means a1 over 1. I want to make sure that if I make this 2, that means n plus 1 is 2. That means n is 1. So a1 over 1, 6 over 1 is 6. Now, if I want this one to be 3, n plus 1 is 3, then n is 2. The previous one is 2. So a sub 3 is a sub 2 divided by 2. 6 halves, 3. If I want a sub 4, according to this formula, is a sub 3 divided by 3, which is 1. And you can write the rest of them on your own. Now, the first term a sub 1 is given as 1. The second term a sub 2 is given as 2. And we are saying a sub n plus 2 is a sub n plus 1 plus 2 is 7. In other words, any term you want, pick the previous one, plus pick the one before that times 2 and add them. So if I want a sub 3, so if I want this one to be 3, this is 2, this is 1. So a sub 3 is a sub 2 plus 2 a sub 1. Again, you can see that, or you can do this, say, okay, I want n plus 2 to be 3, right? So n becomes what? 1. If this is 1, this is 1, this is exactly what you get, which means a sub 2, which is 2, plus 2 times 1, 4. Now, if I want the next one, okay, so we have a sub 1, we have a sub 2, we have a sub 3, the next one is a sub 4. So if I want this one to be 4, this is before that 3, this is before that 2. So a sub 4 is a sub 3 plus 2 a sub 2, which means 4 plus 2 times 2 is 8. The next one is a sub 5. If I want a sub 5, is a sub 4 plus 2 a sub 3. So 8 and 2 times 4, 8 and 8 is 16. And you can figure out the last one on your own. A sub n plus 1 is 2a sub n minus 4, where a sub 1 is 3. In other words, if you want any term, pick the previous one, multiplied by 2, subtract 4. So I have a sub 1, I want a sub 2. A sub 2 is 2a sub 1 minus 4, according to this formula, right? This is 2, that means this is 1. So 2 times 3 minus 4 is 2. The next one, just follow that. A sub 3 is 2a sub 2 minus 4. So 2 times 2, 4 minus 4 is 0. A sub 4 would be 2 a sub 3 minus 4. 2 times 3 minus 4 is minus 4, and you can see the rest of it. Pretty straightforward. Suppose C sub T is the concentration of a drug in a bloodstream at time T. A, the amount of inflow, is the concentration of the drug that is administered at each time step. As time step is very important to understand. That means the patient needs that medication every day, every week, every month, every 2 hours, every 5 hours, and so on. For example, if it's a pain medicine, okay, every 6 hours, every 10 hours. So that time step is extremely important, which depends on a lot of factors, including the weight of the patient. And K is the fraction, percentage, portion of the drug that is absorbed in a time step. So over the course of the time step, 5 hours, 10 hours every day, and so forth, when we give medication, for example, painkiller to a patient, after 5 hours, after whatever the time step is, 10 hours, or after a whole day, a portion is gone. A portion remains in the body, so the patient doesn't feel, too much pain. And then we add. So we want to write the recursion that models the dynamics of drug concentration. So in general, we use N, and of course, specifically, we're going to go to C. So we're going to write N sub T plus 1. That means the next time step is the previous one, N sub T. And then what comes in? Inflow. What comes out? Outflow. So we're going to write N sub T plus 1 is the previous one. Then however amount we added minus however amount is gone. I hope that makes perfect sense to everybody. So next step, whatever we had in the previous step, whatever we are adding gets added minus whatever goes out. This depends on the time step, and the K is the fraction that is gone. Now, because it says C sub T, we're going to change this to C sub T. We're going to change this to C sub T plus 1. Inflow becomes A, and outflow, K is the fraction of the drug that is absorbed. So K times C sub T. Please understand. We change the N to C. So this is inflow A, but what is this? I want to make sure we understand. This is the portion that is gone. And to have a better understanding of this, if we combine these two by factoring, and we get this one, I think it becomes very clear what we are discussing here. C sub T plus 1 is C sub T times 1 minus K. What is 1 minus K? The complementary event. If K is 70%, that means 70% is taken away, is absorbed by the body, by the patient. What is left? 1 minus that. 30% is left. And then we add the A. Why is that important? We don't want the amount of the medication go to 0. Okay? If it goes to 0, then there's a problem. So 1 minus K. And so now, if the initial concentration is C sub 0 equals 120 micrograms per milliliter, and A is 80 micrograms per milliliter, and K is 1/2, plot some points on the graph of C sub T. So to do that, we're going to come up with the first few answers. So having said that, the given is here. You don't have to write this for this, but in general, when you do application word problem, make sure you write the given. It really helps out with the rest of the steps. So C sub 0 is 120, A is 80, and K is 1/2. Into this formula, we're going to put K as 1/2 and A is as 80. Now, it's important to know 1 minus 1/2 means the amount that is left in the body. Normally, it's more than 50% that it's gone, but just for the sake of argument, 1/2 is gone, 1/2 is left. So here's the formula that we need to deal with. So C sub T plus 1 is half of C sub T plus 80. By the way, C sub 0, initially there is no medication in the body of the patient. So the patient doesn't have anything. But in this case, C sub 0 is 120. So since we have C sub 0, the next one is C sub 1. According to this formula, C sub 1 must be half of C sub 0 plus 80, which means half of 120, 60 plus 80 is 140. So according to this formula, C sub 2 must be half of C sub 1 plus 80, which means half of 140, 70 plus 80, 150. Going back to this formula, the next one, C sub 3, must be half of C sub 2 plus 80. So half of 150 is 75 and 80 is 155. And you continue with that. What is important is that what happens if you keep on doing this forever, if the patient needs that medication for some reason forever and ever? How much can you give the patient to be safe? There is a limit. And it so happened that you plot those pairs. For example, the beginning C sub 0 is 120. By the way, as I mentioned, normally this is 0, okay? And as you can see, it tapers off, so it gives you this limit or the horizontal line, and that is A over K. In this case, A is 80, K is 1/2, and we get 160. So this limit, this horizontal line, C sub n is A over K, 80 over 1/2, and it's y equals 160. I'm going to go over the proof of that. For now, you don't have to worry about it, but what is so important about this? According to what they have calculated based on many factors, including the weight of the patient, they have noticed this amount is safe. It will never go beyond 160, and it's safe for the patients. So as far as the proof is concerned, if the limit exists, and we discuss the limit next time, C sub t plus 1 is C sub t times 1 minus k times a, this formula, right? This formula. Assume the limit exists, we're going to take the limit of the left and right, and the limit is equal to some value, x, y, z, L. Normally we go with L to represent the limit. So let's take a limit of both sides. And we said the limit exists. So this one can be replaced with L, and C of t, the limit of that can be replaced with L. And over here, this one is L minus LK, is to cancel each other, and L becomes A over K. That is the proof. And that is extremely important because the limiting factor makes a huge difference.